All right, guys, so we're going to be doing 7-4 equations in quadratic form. So these are going to be some really special types of equations that have to follow this pattern here. So instead of being a x squared plus b x, the variable is being replaced by a function of x. And that function of x needs to be the same and follow the pattern of a normal quadratic. So the function needs to be squared here, to the first power here, and then no function right there. It's really difficult sometimes to notice these, but when you look at the equations that follow this sort of quadratic form, I think it will make sense. So I'm going to look at problem 2 from this page to start things off. We have this. So 2x minus 1 squared minus 5 times 2x minus 1 plus 6 equals 0. So in this case, we have our x squared, or rather our f of x squared. This is our function squared. And then we have the same function, but to the first power. And then we have no other. So this one is in quadratic form. This would have a leading coefficient of 1, right? There's a 1 out there, even though it's not written. So what we're going to do is we're going to do a substitution. And this is a really important skill to develop for the future for calculus, is replacing a common expression or a common function that's part of your equation with another variable. So we're just going to say let y equal 2x minus 1. And I'm going to replace that, and we'll see what our equation looks like now. Our equation now looks like y squared minus 5y plus 6. This substitution has created just a normal quadratic function that we can solve by factoring or whatever method we might have. So in this case, it's pretty easily factorable. We have y minus 3 times y minus 2 equals 0. And that's going to give us our two solutions, y equals 3 and y equals 2. But 2 and 3 are not necessarily the solutions to this original equation up here. They're solutions for y, right? Y is equal to that. But if we look back at our let statement, we know that y is just equal to 2x minus 1. So what we can do is we can plug those values of y into that let statement that I have right there. So I can say that 3 is equal to 2x minus 1, and 2 is equal to 2x minus 1. And now, by solving these two equations, by replacing the values of y that we solved into this definition of what y is, we can solve for x. So we'll add 1 to both sides here, and we'll get 2x equals 4. Divide by 2, and we find that x is equal to 2. So 2 is one of our solutions, but we didn't know that until we actually plugged it back in and solved it. And then we'll add 1 here to both sides. So we get 3 equals 2x. And then we'll divide by 2 on both sides. So we'll go x equals 3 over 2. And those are solutions to this original function in quadratic form. So process is you have to be able to notice this is quadratic form. Notice that you have a common function that's following that quadratic pattern. Make a substitution for a variable. Solve that equation after your substitution, and then take those values that you just solved for, plug them into the definition of your variable. So in this case, plug them in for y, get our solutions. All right, I'm going to go ahead and clear this, and we'll do another one. Obviously, like all the things we've been doing, these can get a little bit harder, a little bit trickier to see. So let's look at, I'm going to do problem 8. So we have 8 is x to the negative 4th. And we have minus 7x to the negative 2 minus 18 equals 0. So it's a little bit harder to see, but this is also following in our regular quadratic form. Again, maybe a little bit tricky to see, but you can see maybe if I write it like this, 1 over x squared to the second power, right? If I were to square this, I'd get 1 over x to the fourth, which is that, right? And then this is really just 1 over x squared minus 18 equals 0. So by rewriting this a little bit in a fancy way, using our exponent rules here to kind of really make sure I'm showing that I have a function that's in common, and in this case it's squared, in this case it's not. We can see that it is indeed in quadratic form. So again, I'm going to make a let statement to create a new variable. I can create whatever variable I want here. Like I could say let u equal 1 over x squared. Whatever variable I want, it doesn't really matter, but that's going to create my new quadratic equation, which should be pretty solvable. U substitutions are something that's pretty common when you get into calculus, so that's why I chose U, but it doesn't really matter here. And this is factorable. We're going to get U minus 9 and U plus 2. That's going to give us negative 18, and yep, that's right. So our two solutions, U equals 9, U equals negative 2. Now, we got to be careful again. These aren't solutions to the original equation. They're solutions to this one. We need to take our original definition of u, which is 1 over x squared, and solve these two equations. So we get 9 is equal to 1 over x squared. And again, this one's going to be trickier because this should have two solutions to it, right? And we're going to get negative 2 is equal to 1 over x squared. All right, so now I'm going to go ahead and solve this. I'll multiply both sides by x squared. I'll get 9 x squared equals 1. Divide by 9, so I'll get x squared equals 1/9. And then when I take the square root, that's going to be handy, but I'm going to get x is going to be equal to plus or minus 1/3. So I have two solutions there. Here I'm going to do the same thing, multiply both sides by x squared. I'll divide by negative 2 in this case. Negative 1/2. Take the square root. Taking the square root, this is going to give us some imaginary solutions, which are fine. They're just imaginary. So I'm going to get that x is equal to plus or minus I root 1/2. We'd love to rationalize this, right? Because we don't want to have this radical in the denominator. So we'd multiply the top and the bottom by root 2. So this is going to be plus or minus I root 2 on the top over 2. I'm not entirely sure if that showed up. I need to move my toolbar out of the way. Yeah, okay, it showed up. So that would be our final solution here. So we end up with two real solutions, positive and negative 1/2, and two imaginary solutions at the end here. All right.